I think we're live. Hello, good morning. I'm Tim Van Milligan. I'm your host here at RockSim Live. Today's another special day because it's not only because you're here, but we got some special announcements as always. The purpose of this episode is to talk about RockSim and to answer your questions. So if you're just joining us, in the comments, go ahead and say hello. If you're watching this on a recording, we do these live every week on Friday at 10 a.m. currently, but we're going to move the time to a different time on Friday. And the reason for that is because I've got another meeting scheduled on Friday mornings that I can't move because it involves other people. So we're going to just move this one. So if you have a time that will be later in the day, that's more that you could still watch, please go ahead and put that in the comments so that we know what that time is. You know, see if there's a time where everybody is available. I've got my monitor over here so that I can watch comments come in. We have Michael O'Brien here, Brian Barbalos, and Rosa, which is really cool. I don't think I've seen Rosa's name before. If you are brand new to RockSim, let me show you where you can find it. I have to open a different browser window here. Let me show you my desktop. Okay, so here's the Apogee website. So our web address is www.apogeerockets.com, and on this web page you will find, there's this scrolling banner, you can just kind of scroll along and you can see it right here, RockSim Updates. You can click there. You can also go to Shop, come down to Rocket Software, and you can get RoxiM here or RoxiM Pro. And if you have an older version of RockSim, you can upgrade here. And I realized I forgot again to make my cursor bigger. I thought about that earlier, and I always forget this. So I need to make the cursor bigger so you can follow where I'm moving my mouse around. Because sometimes I can move it around so fast that you can't see where I'm moving it. If you would like to learn how to use RockSim, go to the How To and Guides menu right up here, and then come down to Software, and then over here you'll see RoxiM Video Tutorials, and I've been updating the RoxiM Pro video tutorials as well. But RoxiM Pro, which we released last week, is very similar to RockSim. On the design part of making a rocket, it's identical. It's only the simulations that are different. So when you go to the Pro video tutorials, it's mostly about running simulations and how they are different. I've updated the first one, the first simulation, and I've updated the one on dual deployment, number 12. I still have to do some of these other ones, but these old videos are still valid because not much has changed, but we just updated the look. So that is where you find it. We did get one question in from Manning Butterworth, and he writes, I am having a hard time understanding the flight simulation results for a multi-stage rocket. In the wind table displayed with the flight simulations tab, I see altitude at deployment. Which deployment? First stage, second stage, sustainer. Ditto for velocity at deployment in miles per hour. Which deployment? So he sent me his RockSim file. Let me see how I can open it here. Okay, so his RockSim file is this one here, and it's a Jayhawk. It's a 3-stage rocket. So here's the first stage, or the sustainer. This will be booster 2 and booster 1. Okay, so this is showing all 3 stages. Booster 1 is this one down here. And then booster 2 is this one right here, which is the middle one. And then finally the sustainers here on top. Okay, so he went to the flight simulation tab, and he's looking at these columns up here. And you can make these bigger just by dragging on them. So he's looking at velocity at deployment and max velocity. And there's other things you can look at. If you right click here on this column header, you can do organize columns. And this will bring up all the different things that you can put into these columns. So you could do like altitude at deployment. You can see that it added it up here on the far end. Time to burnout, whatever, you know, and different things. And then you can change columns around. So if they're not in the order that you want to see them, you just click and drag, and you can move it to where you want. You may have to readjust the size, but now before it was on the end, now it's here in the middle. Okay, so he's looking at this, and the velocity at deployment, he's saying, which velocity is this? And what confuses him even further is if you double click on this, it brings up the simulation details report. And if you look at this, you have recovery system data right here. And so you have parachute, the first one, parachute deployment at 12.9 seconds. Then you have another one at 6.69 seconds. And then you have a third one down here at streamer deployment. So there are multiple recovery devices in here. So this first one here, streamer at deployment, streamer deployed at 4.343 seconds, and then right below it, velocity at deployment of that streamer is 101.6 miles per hour. So I'm assuming that's the streamer. So now we need to find where these recovery devices are inside the rocket. So I'm going to click OK. And let's look at the 2D view of the rocket and see if we can see things inside. So we have a parachute right here. And let's go to the Design Components tab right up here. And when you highlight it down here, it will highlight it in the parts tree. So this is a parachute. There's one right here. And if you can't see this very well, you can zoom in. Just use your scroll wheel. You can zoom in and then click and drag and see this S stands for streamer. So this device right here is a streamer. And we have another parachute in the booster stage, and then that would be down here. So what is happening at what times? So the thing that I've been saying over and over again is that when you're looking at just a table, it can be confusing, and I understand this as well as anybody. So what you need to do is to look at the flight profile of the rocket, or look at the graphs. So let's look at the flight profile first. Okay, so we're going to load the engines in here, and if they're not already loaded, you can just click on the simulation and click Load Engines, and it loads them. That's the fast way to do it. The slow way is to come up here to Prepare for Launch, this button right there, and it brings up this table right here, and it shows the three stages: our sustainer stage, the middle stage, and then the lowest booster stage, which would be this one right here. And then in here we have an Aerotech F-25 in that booster stage, a D-12-0 and a D-12-7 in the top. So I'm just trying to get my sense of this as well. So let's go to the Flight Events tab. Okay, so in the sustainer he's got parachute. In the booster 1 stage he also has parachute, and in booster 2 he has a streamer. And that, Okay, so these may be out of order. Let me close these. Let's just close this for just a second. And I want to go back here to the Design Attributes tab. Okay, and I'll make this, I can't make that smaller. So we have a parachute in booster 1 and a streamer in the middle stage. So let's go back up here. Well, see, this is where it really helps to name things. So I'm going to say this is bottom stage parachute. Click OK. And the streamer, let's name this middle stage streamer. And then let's call this one sustainer parachute. And click OK. Okay, so now the naming, now I can wrap my head around this a little bit better. So if I go here to flight events, okay, so now I can see the things better. So booster 1, bottom stage parachute. See, they're kind of out of order. Here's our sustainer. Then we have booster 1, booster 2. But in real life, you know, it's sustainer booster 2, then booster 1 would be on the bottom. So that's where the confusion comes in, is in the naming convention. So name your devices better so you can kind of tell them apart. Okay, so so the first one is the booster 1 is going to deploy at 4 seconds after separation. So this stage down here, it's going to coast upwards. After it separates, it's going to be drifting by itself, and then 4 seconds later, it's going to deploy the parachute. And then the middle stage, he's got it set at deploy at stage separation. So as soon as it stages, it's going to pop out its streamer. And then the upper streamer in the sustainer, or the parachute, is going to be deployed at maximum ejection delay, and the maximum ejection delay is 7 seconds. So after the sustainer coasts for 7 seconds, then it's going to pop out its parachute. Let's just see what we got here. We're going to launch straight up. I think this is a little short for the launch rod, so I'm going to make it 60 inches. Let's change this to feet. So we're launching at 275 feet with an 8-mile-an-hour wind. And let's see the flight profile. So just click this button down here, and it's going to run a simulation, and then it will bring up the flight profile. So I'm going to kind of cheat here a little bit. So this was his previous one, simulation number 1. And our conditions are a little bit different, so that's why we're getting different numbers right here. Okay, but if you can see down here, there's a 3-stage rocket. So the top stage, the sustainer, its tiny little fins right here are blue. The middle one is purple, and then the bottom one is pink. And then when we click launch, the rocket takes off. And the booster is coasting. And see here, it's right here. And then its parachute popped out, and it's coming down nice and slow. There's the streamer right next to it coming down. The streamer is going to hit first on the ground because the streamer's falling faster. And then finally our sustainer is happening over here. Okay, so let me pause this. And let me turn off the smoke so that we can see things a little better. So what I did is click on Preferences, and then come up here to the smoke effects and uncheck this that says show smoke trails, and then click OK, and it's just going to reload it. So now this time there's not going to be any smoke, and so hopefully we can see things a little bit better. Okay, I'm going to pause it right there. So you can still see all 3 stages right here. Okay, so now we can see the booster 1, which is our bottommost stage, has fallen off, and that happens about 4 seconds into the flight. So now he was wondering what the velocity is. So I'm going to click on the details button right here, and it brings up all the data that RockSim is tracking. And let's see if we can find the data we're looking for. Okay, so we have booster 1 and booster 2. And here's booster 1 velocity. So you have X direction and Y direction, but we want the total velocity. And then we have booster 2 velocity right here at 102 miles an hour. And booster 2 is still connected to the sustainer. So if we look at the sustainer velocity up here, it should be identical, 102.127 miles per hour. Okay, so now we're kind of wrapping our mind around what the speeds are. At this point, the booster 1 velocity is right here, 40 miles per hour. And now we're going to watch this number and watch the screen and see if we can tell when the parachute comes out. Unfortunately, in this 2D flight profile, we don't see a parachute on the booster stage. What we can only see is by looking at the dots. And when the dots are at a consistent spacing apart, we can tell when things happened. So I'm kind of looking at it, and it's very, very hard to see, but all of a sudden the booster kind of shifted. Okay, so here's our velocity. So it slowed way down. Okay, we went from like 29 miles per hour right there, 30 miles per hour, to bam, 21 miles per hour. So I would say at that data point is when the parachute popped out on the booster. Okay, and our streamer, okay, I think that one is also deployed because it is at 17 miles per hour. Let's see. Oh, okay. Remember, our streamer was set to deploy immediately after stage separation. So as soon as it separates, that streamer is just thrown out of the rocket. So we're going to jump from a very high value right here at 100 miles per hour, and it's still attached. And a split second later, okay, its speed went way down. But the booster is still going up. So basically what's happening is it threw the streamer out, but the streamer went downwards, and it's coasting upwards with the streamer coming down, going up behind it. Unfortunately, we can't see that here. We can only tell by looking at these numbers. Okay, and that happens about 4.5 seconds into the flight. And then finally, 7 seconds after motor burnout is when the parachute of the sustainer stage, and that is this velocity right up here. Let me back it up a little bit right there. So we're going 90 miles per hour, then all of a sudden we drop down to 42 miles per hour right there. So that is what's going on there. So I'm going to click cancel. Let's see if we can see this right here. Okay, so the velocity at deployment of that parachute, it says 102 miles per hour, or 104 miles per hour. Let's see if it's right before it pops out, if it's going 104 miles per hour. It's actually going a little bit slower. Okay, so this is probably, I bet you maybe that's one of the other boosters. Let's look down here. So he might have an actual, I can see why he's confused, because I'm confused too, because why is this showing 104 miles per hour? We got to look at booster 1 velocity and booster 2 velocity. So I think is what we're seeing here is that booster 2, because it just, nope, it didn't fall off there. Yes, it did, right? I'm just looking at this little tiny thing right here. The problem with the 2D flight profile is that you can't see things very clear. I'm looking at my comments over here, seeing if there's any other questions about this. We have Brian Barbalis asks, please go over the price structure for RoxiM Pro. I was absent for the last class. Actually, I want to go into RoxiM Pro. I want to look at this very same simulation in RoxiM Pro and see if we can see things a little bit better. But before I do that, let's look at the graphs and see if we can pick up the information here. So we want, I want to do velocity. So this is the velocity of the sustainer. And then we want to scroll down and find, you can't see it, it's off the bottom of your screen, but we have booster 1 velocity. And let's hit booster 2 velocity right here. Okay, so we have, so booster 1 is the bottommost stage. Booster 2 is the middle one. So again, they're kind of out of order. Let me put them in order. If I do booster 2 velocity and then booster 1 velocity, now they'll be in order is the way they're stacked up. Okay, so bottom stage, middle stage, top stage. So bottom stage is black, middle stage is yellowish, and then green. And we're going to end the graph when the rocket reaches when first recovery device is deployed. Let's see what happens if I do that. Okay. Yes, we can see things. Okay, so booster 1 is the bottom stage, and the bottom stage, it looks like we need to see thrust curves. I'm sorry, because thrust curves can tell you a lot. Let's look at thrust. Plot graph. Okay, so now we can, I got to change the colors so we can see this. Let's make that a purplish color. So thrust is going to be in purple. Nope. Thrust is in black, and booster 1 velocity is in purple. Okay, so here's the first motor, and this is the F-25. That's kind of where the thumb is on my hand right there. That's the F-25, and it burns out right here, and that's when the first recovery device is deployed, which is the parachute on booster 1. So right about where my thumb is on the screen. So right there, and if we go across, it looks like it's around 70-ish miles per hour. Okay, and then booster 2, which is the thrust curve for the first D12, and it burns out at 4.6 seconds, somewhere right in there. So right there where my thumb is, booster 2 velocity, and it does look like about 110 miles per hour. And then booster 3, it deploys right here where my thumb is. If I go across, that's probably about 104 miles an hour, somewhere in there. So this graph does show that the sustainer is coming out right at 104 miles an hour. So this actually is the sustainer, which is what I suspected. So it's easier to see on the graph than it is in real life, or on the 2D flight profile. But on the 2D flight profile, you can get a kind of a sense of what's going on. Because here, like this chart right here, there's a little bit of ambiguity. And we don't like ambiguity. Okay. So let me, so Brian Barbalis, before we go into RoxiM Pro, he asked, what is the cost of RoxiM Pro? What is the price structure? And it's a very simple price structure. So if you come down here to Rocket Software, RoxiM Pro, and you come here, and here is the price structure, $30 per month. And that's for everybody. Nobody's getting a better price. There's people that had RoxiM Pro previously. If they want to get the latest version that has the launch visualizer in it, they're also paying $30 a month. So there's no better deal. Nobody's paying more than that, and it's always $30 a month. This is an introductory offer. We're kind of testing it right now until the online version of the launch visualizer is available. So let me open this in RoxiM Pro. So I'm going to go to RoxiM Pro. I want to open that same design that we were just looking at. So I know that's on my desktop. So I'm going to go to File, Open, go to my desktop, and it's this Javelin. And click Open. And I don't care about that design there. Okay, so here's that Javelin again. And I go to Flight Simulations. Okay, and here's that simulation that he had run. Let's open it. This time we're going to do Edit. And what Edit does is a little bit different from load engines. When you load an engine, you're starting a brand new simulation. When you choose Edit, you're using the old simulation. You're loading the engines, but you're using all the parameters that were set up for the previous simulation. So the altitude and the wind, it's bringing that in. Unfortunately, his design was run in RockSim, not in RoxiM Pro. And in RoxiM Pro, there's additional settings that you have to enter into the simulation, particularly the launch location and wind speed. In RockSim, you just set an altitude above sea level. Remember, we set it at like 275 feet above sea level. But now we need to choose the location on the Earth as well as the altitude above sea level. So first let's set up the simulation, and then we'll set up the launch conditions. So the launch conditions are going to be a little bit different. So again, it loaded the engines because I chose to edit. We'll go to flight events, and the flight events are on this screen here. And this screen is a little bit different in RoxiM Pro. We have additional control settings, and this is where RoxiM Pro can get a little bit more confusing. And this is why we say that RoxiM Pro is not recommended for everybody. Because if you can't control your flight events, and it's more complex than RoxiM, then you should probably just stick with RoxiM for right now. So here we have two additional flight events. Remember, we have our parachutes, and I didn't save those names before, so the names reverted back to the original names. But we also have two staging events. So here's our booster, our first bottom booster right here. And the staging event is we want to deploy that at maximum ejection delay. And the maximum ejection delay for that booster motor, that first booster motor, the one over here on the bottom, is 0 seconds. It's also 0 seconds for the middle one, which is the D12-0. So I'm going back to the flight events. So the maximum ejection delay is going to stage at 0 seconds when that motor burns out. The second one, we want to set it the same, maximum ejection delay. Okay, so now we have the parachutes. Okay, so here's our upper stage parachute, and again, we're going to set it at maximum ejection delay, which is good. Okay, now here's the parachute in the booster, and remember, we had that one set at 4 seconds after separation. So I'm coming down here, delta time relative to stage separation. So I'm going to choose that one, and then I'm going to say 4 seconds, and it automatically loaded 4 seconds. Okay, so that one's set. And then the streamer, which is in the middle, that one was also at delta time relative to stage separation of 0 seconds. So this one, so now the simulation is set up the way it was before. So now let's get into our launch conditions. We're going to start at the starting state. And I think we had a 60-inch launch rod, and it was launched straight up, and our azimuth is also straight up. Our azimuth is north. So we've got this one right here. Azimuth is like a compass. So north is up, east is to the right, south is to the bottom, west is to the left. So, but when we're launching straight up, it doesn't really matter what our azimuth angle is, because it's until we angle it at least a smidge of a degree, it's going straight up, and then it doesn't care which way it's pointed. And our launch guide type is fixed to the earth. That means it's going to be rigid on the earth. Starting velocity is 0, so that means when it takes off, it's leaving the ground at 0 velocity, and it doesn't have any roll rate. Let's go to launch conditions. So here we have to choose a launch site. Now, when you get RoxiM Pro, there are no launch sites in it. You have to put in your own launch sites. I have already put in some into my database. So my database, I can choose the launch site, and I can pick a few different ones right here. I'm going to choose this Cloudbusters launch site number 2. Click OK, and it grabbed the altitude. Boy, oh boy, that says that altitude is 21,000 feet above sea level. I don't like that one. That one's like way too high. I don't think that's right. We'll choose this one here and see what that one says. Okay, so this one's 1,497 feet above sea level. And it's got a latitude and longitude, and then here's our temperature and pressure and humidity right there. So let's go to the wind. And right now we have 0 wind. Our wind table shows 0. So I think I have a wind table also saved. I got an 8-mile-an-hour wind from the west. I'm going to choose OK. And okay, so we have the direction. The wind is coming from the 270 direction. So that's west. And it's at 8 miles per hour. Okay, so our simulation is set up. I hope to get numbers that are fairly close to this one right here. The only difference is we're in a different launch location. So we're at 1,400 feet, where previously when this was run in RockSim, it was 275 feet above sea level. So I am expecting this altitude to be a little bit higher than 395 feet because our air density is lower at higher altitudes. So I'm going to click Flight Profile, and it's running the simulation. It's running 10 of them. I only need 1, so I'm going to cancel this. I'll just let it run because it's doing it pretty fast. So you can see the number of uncertainty runs right now. An uncertainty is, are you sure of every condition that you set up? Are you, for example, are you exactly certain that you're launching exactly at 0 degrees elevation angle, or your azimuth angle? Are you absolutely sure that the engine is going to produce exactly the amount of thrust that the manufacturer specifies? Those are uncertainties. Those are the things that we don't know. And what was set up previously was 10 different uncertainty runs, and I don't know what they are, but in the flight visualizer, it only looks at the nominal case. So here is the rocket sitting on the launch pad, and I'll zoom out like you are seeing it here, and this kind of gives you kind of a sense of perspective on the launch here. So the launch pad is right here. We're in the middle of a farm, and I can move this around, and I can kind of see over here there's kind of a valley, or a little ridge, but mostly it looks pretty flat. Okay, and I've got the view right now to show the rocket, keep it centered in the screen. So if I move the rocket over here and I click the launch button, it's going to jump right back to the middle of the screen to keep the rocket centered in the screen. There's other views. There's a trajectory view, which means this is kind of my favorite one. A trajectory view is keep the camera steady. Don't move the camera at all. The rocket is going to do whatever it's going to do, and the camera may or may not see the rocket. So you may need to back out a little bit so you can see the overall trajectory of the rocket. Okay, so I'm going to move the rocket down to the bottom here. You can kind of tell by the cone right here exactly how high the rocket's going to go. And I'm going to click the launch button and see what happens. So you can see the rocket over here in the corner, it's taking off, and then over here in the main view we're seeing the trajectory. And it's kind of small, so I'm going to start zooming in a little bit so we can kind of get a sense of what's going on. And at this point the rocket has reached apogee, so that red dot right there is my apogee point, and the color coding on this dot is critical. The red means that the rocket weathercocked outside of the weathercocking cone. So here's this cone right here, we call it the weathercocking cone, and we want to see that apogee point inside of the cone. That means the rocket's going more vertical than horizontal, and that's safe. So this is kind of telling me that this trajectory might not be the greatest thing in the world. But let me back the time up. I want to move, the rocket is right there. So I'm going to zoom in on the rocket. And at this point, did the parachute come out? So the parachute had just deployed right there. Okay, I'm going to back it up. So here's, the rocket's over here off to the right. I'm backing it up. Okay, so here's our apogee point. We're at 1,199 feet, which is right there. I'm looking at the maximum altitude column, and that's the apogee point. Let me zoom out, and let's see where those booster stages fell off. I'm going to back up my timeline here. You can see the smoke is coming out of the rocket, and I need to go further down. Okay, so here, these yellow and blue lines are the other stages, and I'm going to back up down to. Okay, so when this blue line first appears, that's when it's we have separation. And if I zoom in, let me turn off the smoke right here. So I'm going to go here to the preferences, and I'm just going to turn off my smoke. And I want to turn off the weathercocking cone, and that's under the flight screen right here. Here's display the weathercocking cone. I'm going to turn that off, and that makes it a little bit easier to see the rocket. So our rocket is right here, and here is another stage. If you click on this button right here, this finds the rocket wherever the rocket is, and it puts it right in the middle of the screen. And once it's in the middle of the screen, then I like to use these zoom buttons down here because I don't get lost, and it zooms exactly in the middle of the screen. So here's my sustainer, and the flame is kind of separated because it thinks there's it's having a hard time figuring out the geometry. It thinks there's two stages still below it. But then right over here, this blue line is the streamer of, oops, so yeah, I lost it. Find my rocket. Let me zoom out a little bit. Okay, so here is the middle booster right there. And I lost it again. So the green line right here is the trajectory of the sustainer. The yellow line is the bottommost booster, and then the blue line is that second booster stage. And I'm just clicking and dragging and following them up into the air. So here is the bottommost stage, and its parachute is not out yet. So I'm going to zoom out a little bit, and we're going to move the timeline until, there it is, right there. So it was just, it kind of coasted upwards because it was stable, and then the parachute did deploy. Okay, so that gives me a much greater sense of what is actually happening. And let me go this all the way back down to the ground. So you can see the streamer is definitely falling faster than that parachute. So here's the parachute, here's the streamer. and they're both going to land right there. So the streamer looks like it landed right on the edge of the road, and then the parachute landed over here. This looks like some kind of grove of trees of some sort. And then our main parachute is right here, and it's not down yet. It doesn't get down until total flight time of 47 seconds. And it landed over here. It's actually not too far away from the launch pad. It's only 84 feet from the launch pad. So our launch pad was right there, and our parachute landing point was right there. And if you look at this, everything is in a straight line. And that's because we launched exactly straight up, and we didn't have any forces pushing the rocket upwind or crosswind either direction. And if you want something like that, then you'd have to change your simulation. So let's run the simulation one more time. Let's change the azimuth. Let's angle the rocket a little bit. Let's see. Let me angle it around so north is straight up. Okay, so our launch pad was somewhere right here. So this next launch, let's launch it kind of to the northwest, so that when it deploys, what we expect is once it deploys, then it's going to drift straight east because we have a wind coming directly from the west. So I'm going to close this. Remember those uncertainties that I did before? That's this button right here. It's not going to, these are all going to be also in a line. Let me click on, so I clicked on this uncertainty. So this is going to show me my uncertainty. This is called a splash pattern, and I have two ways of displaying. I can display it in RockSim, or I can display it in Google Earth. I'm going to show you RockSim first. Okay, so here's the chart. Okay, so our launch point is a green square, and I'm not seeing the green square anywhere. Where is my green square? It might be under here. Everything is landing in the same spot, so it tells me my uncertainties must have been pretty marginal. Let's go back to that. Okay, so we want to set it up to, let's angle this. I don't want to go 33 degrees. I want to go more straight up. Okay, so we're 88 degrees. Oops. I want to go this direction. In RockSim, I can go a plus or a minus elevation angle. So I can go this way or this way. But if you use a negative number, what it does is it changes your azimuth direction 180 degrees. So if I want to launch to the northwest, kind of like it's going right now, I need a positive launch angle. So at this launch angle, I'm going to the northwest. If I make it a negative 19 degrees, like here, I'm actually going to the southeast, and I don't want that. So I always want to keep this button or this dial always at the positive. Okay, so now we're going to go 7 degrees from vertical towards the northwest. And let's see that. Let's see what the uncertainties were. Yeah, there was a bunch of uncertainties, but I have 0 set up here. So why did it run it 10 times? It shouldn't have run it at all. Okay, so this time it's only running it 1 time. Oh, I know why. Because the previous time I chose edit simulation, and so it grabbed those values. When I just do run a new simulation, now it's whatever my current values are. Okay, that makes more sense. I'm not going crazy. I'm looking over here. Is the visualer working on MacBooks with Big Sur, writes LB And the answer is no. It's still not working, and it probably won't for a long time. And the problem is not with RockSim. The problem is with Apple Computer. They didn't make Big Sur cross-compatible with old software. So if you want to blame somebody, blame them, because they keep breaking things. This is why we're launching the online visualizer, because we're tired of Apple and Microsoft breaking our software. Ethan Edwards writes, "Hi from New Mexico. I was wondering if RoxiM Pro takes into account motor efficiency losses due to launching at high altitudes." And the answer is yes. As you go to higher altitudes, the thrust changes. It's kind of like, you hear about SpaceX designing engines for sea level launches and then for vacuum launches when you're in outer space. And basically the nozzle diameter has to change and the throat diameter changes. And if they don't change, then you're going to get losses. And that's picked up in the equation. So yes, that does account. And Wonder Bucket Bryce. Wonder Bucket is Michelle, and she is answering Bryce. What was Bryce's question? Well, there's a whole bunch of questions that I missed. I don't see Bryce's question. I cannot download RockSim. The page opens and then closes really quick. Okay, and Michelle wrote, Michelle is Wonder Bucket, and she writes, you can try right-clicking and download file rather than just clicking on the link. For some reason, Windows has problems with links that we send in emails. Okay, so let's get back here to the visualizer. So we have the rocket sitting on the pad, and this time if we look at it, we should be going to the northwest. So north is the black. I'm going to rotate it around so that we're pointing straight up. So north is straight up. And then if we look at the rocket, yes, it is kind of pointing to the northwest. And let's angle this a little bit. And I'm going to go back to my trajectory view right here. And it spun things around. Oh, I changed launch sites too. Why did it change launch sites? Because previously I did edit. This time I ran a new simulation, and my new launch site is at a different location. And you can see down here we're at the Ohio River. And let me zoom out and give you a better perspective of where this launch site is. Okay, so here is Ohio. I don't know if you can see that, but here's Ohio. And here's Indiana. Here is Kentucky. And if you lose your launch site, click back up here on this button. Oh, and it found it. It's directly in the middle of the screen somewhere. And now we need to zoom in. I don't think it's, yeah, okay, now we zoom in. And if I keep zooming in, so there's Ripley, Ohio. So we're here right on the Ohio and Kentucky border. And right here, this looks like to be a school because you can see somebody's cross-country track there. Okay, so there's the launch pad right there where my cursor is, and I'm going to rotate the image. And I'm going to back up a little bit. If you can keep the entire cone in the screen, then you can be assured that the entire trajectory, the apogee point, will be within the screen as well. Okay, so I got this water hazard here called the Ohio River that I want to avoid. Let's launch it and see what happens. So the rocket takes off. Booster 1 falls off. Booster 2 falls off. Now our sustainer is going up. And it is going towards the Ohio River. And right there, the parachute popped out. And it looks like now it's going away from the river, which is a good thing. And I'm going to speed things up. I'm going to go all the way back down to the ground. Okay, so here's where the sustainer landed. Our first booster landed right there. Looks like on top of a building. And the middle booster landed there. So I'm going to change the view. I'm going to rotate it around, look at it more from a vertical perspective. Okay, so right there was the launch point. The rocket took off and arced this way. That booster fell off, and that's where its apogee point was. That was where the second one was. Notice the color again. Remember I said green is good. Red is, it's kind of going more horizontal than vertical. And then here's the apogee point of the sustainer. And it landed kind of near that track. This one landed on a bus, and this one landed in the corner of a parking lot. Can't see what that is actually there. The resolution on that map is just not the greatest. So that's RoxiM Pro. I got to look at my questions because I don't know if we've gotten them all. Bryce Dwell writes, Tim, I am the kid with red hair you talked to about the Texas competition. Oh, what is the Texas competition? We had Bryce and his family. I think Bryce, I can't remember your age, but you were a young man, probably around the age of 11 years old. And he came to our office, and I was talking to him about the Texas competition, which is actually the World Space Modeling Championships. And in 2023, it's going to be held in Texas, in the Austin, Texas area. So, and this is the first time since 1990 that the World Space Modeling Championships has been held in the United States. This year, it's being held in Romania, and I will be attending that in Romania in October. But in Texas in 2023, it'll be in August, and all the other countries are going to come here. But the thing is, we need young kids, particularly young kids under the age, currently under, if they're 17 or under today, they'll still be young enough to compete in 2023, because you have to be 18 years old, or you can't be 19 years old as of December 31, 2023. So if you are a kid, or if you know a kid that would be interested in being a world champion, this is the event that they need to go to. And you can go to the NAR website. Let me go to the NAR website I'll show you where you can get information on it. So it's nar.org. And then you need to go to contest flying, and then there should be international competition right here down at the very bottom. You select that, and that will tell you about the competition. They haven't updated this yet for the Texas competition, which is the World Space Modeling Championships. But this is where you will find information, and there's like 9 different events, and you don't have to do all the events. You can pick 1 or 2. There's a lot of people that just specialize in a certain event. You know, there's streamer duration, parachute duration, helicopter duration, glider duration, RC glider. There's scale altitude, and egg lofting. So you can pick 1 or 2 events and become really good, and then try out for the team. The tryouts are probably going to be next year. So you got to be doing this like right now, starting to get prepared. And then you try out for the team. Once the team is selected, you get a little bit more time to prepare for the World Championships, because then you have to be really good. So between now and next summer, build a lot of rockets. That's the best way to get really good. Get really good at flying rockets. Get really good at deploying your recovery device at the right time. Use RoxiM Pro. That's all going to be very important. So that's what Bryce is talking about. So we want, I think the objective here is we would like to get every NAR section in the United States to get 1 kid to try out for the team. And if every NAR section did just one kid, we would get probably close to like 150 kids trying out for the team. And then from that, we could select the best of the best. And you have to, you have to earn it. They're not just going to place you into the team. You got to earn it. So you got to be good, because you're going to be competing against the rest of the world. You're going to be representing the United States. Here's a picture of the U.S. team from Poland, where we went to Poland, and two of these girls right there on the podium winning gold medals were from the United States. And if you're watching this video and you're not in the United States, you can still compete at that World Space Modeling Championships, but you're going to compete for your own country. And we would love to have you come. I think I saw somebody from India on the list, and I don't think India currently has a team, but you can form a team. You just have to figure out, you have to go to the FAI webpage in order to sanction your team. And the FAI is a French organization. If you click on FAI over here, they'll list all the rules of creating a team and getting it organized, and so you can compete for your country. And we would love to have you. The more teams, the better. Let's spread rocketry all around the world. I got two more things, and I'm running out of time. One is we want to give a poster away. So let me change screens here. Okay. And my screen is not updating. So here is the poster we're giving away, and it is a new rocket, and this is the Zephyr Junior. So you may have seen our big Zephyr, our big high power 4-inch diameter Zephyr. This is a half scale version of that. It's 2.2, it's almost half scale, 2.2 inches in diameter. So for people that love the big Zephyr, now you have the little Zephyr. And we have a one-of-a-kind poster that I'm going to give away. And I'm going to let Michelle, she's going to pick who the winner is, because she's been reading all the comments, and she's going to pick the best comment from today. And then we will send you this poster. And, whoops, there's the poster. Somebody's saying it's frozen. Why is it frozen? I have no idea what happened. Is my voice frozen or just the screen frozen? The screen froze. I'm going to stop streaming and I'm going to restart, and hopefully that will fix it. So